Welcome to Ron's Holiday Lights. Today I'm going to give you an introduction to my controllers and wiring options. So my controller has a standard connector on it, and it's the same on all of my controllers. And I have a variety of adapter cards that you can attach to the controller. If you don't like mine, design your own. The first one I have is a pixel extender. The next one is a power over Ethernet, and you can see I put fuses on those to limit current, direct drive, and a matrix adapter. The nice thing about this controller is for spare parts, all you need to buy is the Ethernet adapter and the FPGA board, which is about $25. Direct drive is the first example for wiring, and this is where you directly drive the lights off the controller. You can see I have a 5-volt buffer board, and above that is the power supply where I'm inserting 5 volts into the cable. I have 10 feet of extension cord cable, 16 gauge, and then it's driving the lights. My concern with this is the ground change between the controller and the lights, and as you can see, as the lights changes, the voltage on the ground varies. Ideally, you don't want this to be very big. There's about a half a volt of margin on the input to a controller, so you can see we're well within that. If you wanted to zero that out, you could use pixel extenders, and that way the receiver would be tied to the ground at your first pixel. Next thing I'm going to show you is a pixel extender. This can also be used for DMX and Renard. If you look at my controller board, I have a small board attached, and it basically has some 485 drivers on it and 4 Ethernet connectors, so it can drive 4 cables. There's 50 feet of Ethernet cable, and then on the receiving end there's a small board with a 485 receiver, and the power is injected there. Next, I'm going to show you power over Ethernet. Connected to my controller is another small board that's similar to my quad buffer, except it allows me to insert the voltage from the power supply. This board also has 4 fuses on it to limit the current in the Ethernet cable, and inputs for the power. This is 50 feet of Ethernet cable, and at the receiving end there's a receiver board and a DC to DC converter. This converter takes the 36 volts from the power supply and drops it down to 5 volts. I've taken off the resistor pod on the board and put in a fixed resistor to fix the value. And the receiver board is basically a 422 receiver. The voltage drop across the Ethernet cable is about half a volt at 50 feet. Next, I'm going to show you the matrix adapter. It supports both 8-to-1 and 16-to-1 boards, and you only need one adapter, and it can drive 8 of the 16 by 32 boards or 2 of the 32 by 64 boards. Thanks for watching.